Hey, so welcome everyone. This is the Nephew SIG Security Meeting. Thank you for joining. So today we have few agenda items. So one uh, uh, regarding the Chekhov installation and trying out Chekhov on some of the code repository. That's one point that we want to discuss. The other is from the spiffy next steps. What are the things that we can handle is something that maybe Prashant you might want to give an update. Last time we discussed about specific things, right? Like uh, the using the Kubernetes resource model for the vault related aspects as well, right? Is there anything else, Prashant, that I'm missing?
No, no.
Okay. Uh, so regarding the issue number, the reason why we started working on Chekhov was there's this issue raised number 786 uh, on the Nephew project GitHub repo. And that issue was raised by an external pen tester who happened to have checked that some of our service accounts are overly provisioned. And hence, we said that, maybe using checkout would be a good idea. Uh, so I think Ved, you have tried out checkout, right? Like on the existing code base, or did you had a chance, or anything that you would like to bring to this table?
Uh, yes, hello everyone. I've been trying Checo. I've been trying it on a Nephew catalog repo. So I was able to scan some of the sample YAMLs. I'm checking it out. How can we integrate it with the current Nephew workflow before deploying the infrastructure? How can we make sure that everything is in compliant and is not breaking anything as identified by Checo?
Do you think we can bring the get the report and then bring it for discussion here, or we can even upload it on the conference, the Nephew Wiki conference?
Yes, sure. I'll share some of the logs and outputs which I'll be receiving after doing some more like kind of research in this, and I'll update it.
Okay, okay,
Sure.
okay. Thank you, thank you. So then moving on to the next action item, which is Prashant. Maybe you have anything to say, anything to update about?
Yeah, I was going to show a demo, but I had some other like
Okay,
other work, so I guess I'll have to delay it by a week.
okay. So we're planning on next week. Is that what?
Yeah,
Okay, let me just add some notes here. So first of all, in the context of uh, what Ved said, uh, but in general, Prashant, do you think that that is a project that we can make use of the Red Hat COP project?
yes, I've tried it and it is working. I just need a setup demo with respect to nephew.
Okay, okay, okay. Okay, I'll update the so this wiki page is acting up on me. I'm not sure what's happening here. There's some changes that are happening to wiki on a regular basis. I'm just worried that we might lose some of the information that we have been keeping here. So anyways, I'll update this later. The so if you think cop is okay to be used, then we can okay. Uh, uh, we can uh, we can go ahead about that. Another thing that came to my mind, Prashant, was that should we actually depend upon the vault? There is no dependency as such, right? Like the between the workload identity and the vault itself.
No,
Vault is just
workload
another.
identity as a separate thing is fully functional. Vault is just a demo part of it.
Yeah, yeah. So in that case, we should actually try to close that part first, in my opinion. There's no point in. I'm not sure if there is a value in actually having both those things together at the same time. It would result in bigger this thing. What do you call review cycles? And I'm not sure if we want to put it up together.
Okay, then I'll make an official pull request for Swiffy on the nephew
Yeah,
repo.
yeah, yeah, yeah. So raising a pull request early would be better than keeping it for later.
Okay, it would be without all the vault things.
Yeah, without any of the word stuff.
Yeah,
Yes,
okay.
word stuff can be a separate PR altogether. It deserves to be a separate PR.
Yeah, yeah.
Okay. The only other discussion that we have right now is I've shared a document in the on the Slack channel. I've received few comments. Thank you, Ram. Ram is here. We said that we'll be discussing some of those aspects in the call today. If is there anything else that someone wants to discuss in the context of what the existing action items? If not, we can move on to that discussion. Okay. Uh, right. So Ram, do you want to explain what the thought process was there in the context of attestation?
Yeah, hi Ragul. Yeah.
Yeah. Yeah.
So general this keylem is about performing remote attestation procedure for system integrity generally, right?
Mhm.
So this was CNC of this is CNC of
Yeah.
sandbox project.
Yeah.
So they created, so as you have written in the document, there is multiple plugins that you can use it with Spiffy.
Right.
So they have also, the Red Hat team and the Keylem team, they have also developed a plugin to be used with Spiffy.
Right.
So primarily what this Keylem does is, uh, so you're supposed to store all the golden configurations, SHA values or whatever golden values in the register, right? So
Mhm.
there are three components in the Keylem, the agent, register, and the verifier.
Okay.
Uh, so what happens is that the agent can be a binary or it's a daemon set that you can have it in your environment, and it can two things it can monitor. First one it can monitor is the PCR, platform configuration registers. So these are uh, these are the platform values which are exposed to the TPM. So basically, it contains your BIOS SHA value, kernel SHA value, and whatever additional things that you want, you can write it. And the TPM provides attestation, and this agent takes these attestations and
Mm.
shares it with the register verifier, and the verifier will compare it with the golden value that the user has provided. So what happens is this continuously this is performed.
Mhm.
So this is primarily, see, there are two types of attestation as per IETF. So one is challenge response, where it means that a centralized entity keeps challenging you with the nonce, and you produce evidence through any TPM or any root of trust, and you produce it and it verifies it. Other way is passport model, where the agent itself presents it and like a passport, and the verifier verifies it. So my question was, if there is a frame, I mean, if we can have a framework to revoke the issued SVIDs,
Mhm.
does it even, I mean, does it make sense? Because I was recently working on, I mean, just seeing about KLab. So
Mhm.
I was just thinking, since already the Spiffy, it's plugins there, it's available. So, uh,
No,
so
so in general, let me just comment about revocation. That's an interesting and important point that you brought up. Uh, so in terms of revocation, what Spiffy says is that it doesn't support any of the existing OCSF or no, not OCSF. What is that? OCSP, right? Like there are two revocation mechanisms: CRL and certificate revocation list, and OCSF, some other format. So Spiffy says that you should have your lifetime to an extent where the key rotation will automatically happen. So that's what the guidelines is from the documentation. So your the overall the amount of time for which you keep the key
okay.
should be less, and that's automatically taken care of. If it is few hours in our enterprise solution, we make use of few hours for for this for the cert to have this value. So the good part is that none of the private keys are maintained anywhere on the disk. It's completely with the Spiffy server. And worst case, if the Spiffy server restarts or something happens, it has to be reinstalled. Then everyone will go into re-attestation. Everyone has to do re-attestation when the next time it tries to connect to the specific control plane. So that's the only caveat here. But in general, no, there is no requirement to actually keep any of the private keys in persistent storage for any of this purpose. That's another advantage of using like attestation based mechanism for identity.
Okay. Okay. Okay.
Yeah, but I saw Keylime, and Keylime seems a very interesting project. I think I've seen this like a couple of years back. I didn't knew that they have also they're also part of Sandbox now,
Yeah. Yeah. Yeah.
CNCF, but that was an interesting thing. But my understanding is that, so the other part that you mentioned about continuous attestation, right? That basically triggered my attention, and then I was trying to understand what was the use case and the point.
So here, what happens is you can, I mean, the exact same use case that you can bootstrap Trust using Keylime. So you can install the agent in any cluster that you don't trust, and once the agent once the agent proves its integrity to the verifier, then you can issue a certificate, MTLS certificate or whatever certificate that you want for your communication, right? So what happens after you issue the credentials? It keeps monitoring the platform. So monitoring, I mean that it can monitor complete hash value of all the files that is present in the system, all the files that is present, so that IMA exposes that value. So it continuously signs this and sends it to the centralized verifier, and it can also monitor platform level changes like OS version, kernel version, or anything that is there in this version. So what happens? You can configure to produce this attestation every 1 second or as soon as possible. So the control plane keeps on challenges the agent to prove its integrity, and the agent produces signed evidence, and verifier first checks the integrity of the claim. Then it also verifies whether it has actually come from the right TPM. If it's all fine, then nothing happens. But in between, if there is some file is changed, for example, someone has hacked the system and file integrity is
Mm,
changed, or someone has flashed the
yeah,
wrong bias. So then what happens immediately? I mean, this keylem provides you a framework to revoke the certificate also. So the agent will give a revocation notification which will revoke the certificate it's
I
used,
see.
and the agent can, and in whatever revocation action you have put it in the script, it will execute.
Hmm. So maybe the revocation part may have to be clarified in the document as well. Maybe this could be an action item. The strategy has to be clarified.
So my question, I mean, my original question was, should we leave this to the plugins to do the particular revocation? Here, for example, it's a empty shell script. So here
Mm,
also I can manually revoke the SVID or delete the SVID, something
mm,
like that. Or should we have this, I mean, this general revocation framework in the SPIFFE or there itself? That was my
mm. At least for phase one, I think this is a good topic, but maybe for phase one, this would definitely be an advanced thing to
yeah.
handle.
Yeah.
So having just assuming, but that assumption has to be clarified in the maybe the document. You can
Mm.
just say that the revocation is going to happen uh, using this the like whatever is default revocation procedures that are mentioned as part of SPIFFE, and SPIFFE has documented it. I think I've seen it somewhere on this page. Those same things will refer. Uh, right, but the use of TPM and both in Linux IMA, right? Like that's an interesting way to get attestation done. So that's I need to understand how the plugins actually operate. But a lot of those things might not be applicable basically because on the general Kubernetes environment, primarily because Linux IMA is not generally applicable or available on all the
Yeah,
platforms.
correct. So this inside containers, this doesn't work. That is the problem.
Yeah,
So,
yeah, yeah, yeah,
that
exactly. So
there are some ePPF programs are available to expose it, but still in the POC phase.
yeah,
So
yeah, it's very early stage. Yeah. Yeah, we wanted to make use of Linux IMA for some other purpose. Linux IMA is Integrity Measurement Architecture, if I
correct,
remember well, the full
correct,
form,
correct, correct, correct.
and it allows you to, if there's any change on the disk in certain this thing, it allows you to check the integrity and take certain actions. For
Correct.
example, you might say that I want only processes with these hashes to be executed, and Linux timer will allow you to just do that. So that tomorrow, if someone overrides the binary or someone tries to upgrade the process and they try to execute that, the process won't be allowed execution. Things like
Correct.
that, right? Like so, those
Correct.
kind of use cases.
Right.
Yeah. Okay.
Okay.
Cool.
Thank
Thank you.
thank-
Thank
yeah.
you, sir. Yeah, so let me just quickly go through this and show one diagram which based on which we had discussed last time. Uh, I want to just bring up so that so this was the diagram that we had discussed last time. And since Wim is also here, Wim is here, right? I saw Wim. Yeah, Wim is here.
Yeah,
Uh,
I'm here.
yeah, yeah. And so I've given some instantiation here and check whether if it makes sense. It would be really useful to get a approval on this particular diagram from your side. Yeah. So the intention here is that the developer pushes the workload blueprint into the Nephew catalog packages, and that blueprint contains the base workload package and the security package. I'm just calling it workload security package,
Yeah.
right?
Mhm.
And this becomes the input for Porch. Porch then leverages specializers and mutators and then converts it into individual deployments, right? H01 and H02, and they will
Yeah,
have their.
that's a nice drawing. Yeah.
Thank you, thank you. And it's completely based on what you showed last time. So,
Yeah, but this is a way better representation. So I like it. Yeah.
thank you.
Nice.
And here is a sample Porch
Yeah.
specializer mutators example that I've given here. So cluster H01, H02, my namespace and the service account, right? Like gets appropriately changed here. That's the
Yeah.
only
Nice.
difference.
Yeah.
And it gets pushed to the corresponding edge repo, and then the corresponding config sync picks up and everything. So the point is in the management repo, part of this, right? Like the identity information goes into the management repo, and the
Yeah.
other part goes into the edge repo, and then the config sync handles it, right? Like that's the overall thing. Then the workload
Yeah.
comes up, it does the attestation. The registration of these workloads happen through this config sync creates the resources. These resources
Yeah.
are consumed by the Spire server, registers the workloads, and then the workload when it starts up does the attestation, and the SVID is received.
Yeah.
Okay, yeah, all right then. So this is anyways, this is the same thing that is mentioned in the document below with some details. Yeah, hoping that this could be serve as a
I'll read it. It's on my to-do list to read it, but
thank
it
you,
looks good from my point of view. At least the first impression is yeah, well done. Yeah,
thank you,
nice.
thank you, sir. Thank you.
You should actually help the user guys because it's a very nice representation.
Thank you. Thank you. Okay. Okay. Thank you. There's nothing on the agenda apart from this, folks. Is there anything else that anyone wants to bring up for the discussion? Next week we are hoping to see two things: a demo from uh, 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 Prashant with Vault. If not, at least Prashant, if we can target the PR, raising the PR, right? Like in the next call, like getting the PR up and ready for review.
Yeah, it'll be available this week only.
Okay, fantastic. Thank you. And the other part would be the checkout report, right? Like these are the two things that we are targeting, and hopefully we should be submitting the document that we have prepared to the Nephew team as well at large. These are the three action items. Anything else? Okay, thank you. Thank you, everyone. Have a good day, good week ahead. Thank you for joining. Thank you. Thank you, folks.
Thanks, Rahul.
Thank you.